Are we ready?
Yeah.
All right, so we're going to talk about energy today. And energy is basically everything that allows us to do anything. So there's a whole bunch of different types of energy. In food, here I have my own snack here, there's what we call potential energy. And what potential means is just means it can do something, but it's not doing that thing right now. So what happens with this potential energy in food is if we eat it, eat your snack, let it get in there. And now what our bodies do, it takes that potential energy and it turns it into something useful, like kinetic energy, which means kinetic means movement. So what we're going to do now is we are going to help our bodies do that work, and we're going to turn that food energy into dance party energy.
You gotta get with my friends, make it last forever. Friendship never.
So our bodies and all sorts of living things do that all the time. They take food and turn it into movement or growth. Like when you feed a plant sunlight and water, it takes that energy and it grows with it, and it makes new leaves and it makes new plants and stuff. So all plants and animals do that particular fun trick where they convert, which just means change energy from one form, like potential, into another form, like kinetic or movement. But humans can do all sorts of other cool tricks with changing energy. We can take wood and we can light it on fire. And this is another way we change energy around, right? So we take the potential energy that was in the wood and we light it on fire, and then it releases that energy as heat, which is another form of energy.
So far we've got potential energy, which is just kind of in stuff, not doing anything. Kinetic energy, which is movement, and heat energy, like the heat that comes from fire.
Yes.
And the heat that was in our oven that baked our biscuits.
And lava.
And lava also.
Lava gives off a lot of heat, that's right. We could do all sorts of fun tricks with heat, like we could cook things and we can warm ourselves. But a little while ago, we discovered a brand new, well, not brand new, it was always around, but new for us form of energy called electricity. And with electricity, we realized we could do all sorts of cool magic tricks. We could turn on lights rather than having to light things on fire all the time. And we could do things like have video chats with each other. And we can talk to each other when we're super far away and watch TV. And
yeah, we're using electricity to talk to each other on the phone.
So humans love electricity because energy in electrical form lets us do so many different things. So once we figured out how cool this new form of energy was, we wanted to use it all the time. So we had to figure out ways to make it because we couldn't really find it in nature very often. There are some ways it shows up in nature. Like, have you guys seen a lightning storm? Because we wanted to use electricity all the time, we had to find more ways of making it. So what we did is we knew that we could turn kinetic energy, that movement energy, into electricity. But we had to make more kinetic energy then. And we had to do more than just dancing around for this. There was too much for us to make. So one way we found is by burning really, really old stuff, older than wood. You remember how last week we were talking about amber as really, really old tree sap? So there's tons of other really, really old things that have lots of really concentrated potential energy in it, like coal. So we found if we lit something like coal on fire instead of wood, it released way more energy. And we used that heat in order to turn a turbine, which is basically just a spinning engine thingy. And that way we were able to make electricity. We found other ways of doing that as well, though. Another way is we put up big fans out in really windy places. With wind power, we don't have to go through all the hoops of generating the heat and then also changing the heat energy into the movement energy, and then also turning the movement energy into the electricity, because anytime humans are kind of new at changing energy on purpose, and we end up with losing a lot of it every time we change it from one form into another. So even when we ate that bit of food and then turned it into a dance party, we didn't turn all of the potential energy into the dance party. We lost a little bit of it because we don't have a ton of efficiency, which just means, how good we are at capturing all of that energy and changing it. So with wind turbines, they're a bit more efficient than coal because they don't take as many steps. We don't have to change energy into as many different forms in order to use it as electricity. Another similar way is with water. So we take like a rushing river or something and use that to turn around. With water, that's how we get 95% of our electricity here in BC. We don't really use coal here. One way that we don't have to turn it into movement first, so everything we looked at so far, that's finding a way to make something spin so we can turn that spinning activity into electricity. But solar power, there's tons of energy that comes at us from the sun. Actually, that's how plants get a lot of their energy to grow and stuff, is from sunlight. So we take that and we use the sun energy to turn into electricity from there. And we don't have to have those big turbines for that one either. All right, now things get a little complicated. So we talked about different ways that we can turn energy that lives all around us into movement. So spinning those turbines and stuff like that. But then how do we turn that into the electricity that powers our phones? So I want you guys to go over to the fridge and grab a couple magnets. Can you do that? Okay, so what we're gonna do is, like, very slowly and gently, I want you to put your magnets together. And I want you to really feel what that feels like. Do you feel them kind of pulling together or pushing apart from each other?
How does that feel when they're really close together but not quite stuck yet? Does it feel like they're pulling close together, or does it feel like pushing apart? Pulling close together? Yeah.
Magnets are very, very cool because they move stuff around, especially metal stuff. And one of their favorite things to move around is copper. You guys have seen pennies, right? Those are still around, right? Pennies? Okay. Pennies are made of copper. It's that really fun orangey metal. And we also use copper for electricity. And the reason why we use copper is because, okay, so you remember last week we talked about tardigrades and how they're really, really, really small? And even smaller than tardigrades, smaller than anything you can see, are little bits that make up everything around us, and these are called atoms. Very, very, very tiny things that make up everything, including us.
In Magic School Bus, I saw some atoms in a boy named Ralphie Whittle.
That's great. So you already know about atoms. That's awesome. So inside atoms, there are these little, even tinier things called electrons. And you notice how similarly the word electron is to electricity?
Yeah.
So everything has these, but in copper, the electrons are big partiers. They love dance parties. They like to move around and like move over to other things and come back and hang out, which is what makes copper really special, because lots of other things their electrons don't like to party as much. They like to stay at home and quarantine. So all that jumping around of the electrons in copper is what makes electricity. So you see how he's kind of wrapped up this little light bulb in that orangey copper? All right, so now he's gonna get a magnet and he's gonna put them together. And you see, when the magnet gets close to the copper, it's like starting a big dance party for the copper's electrons, and that's what lights the light bulb up. So all that dancing around and party time of the electrons from copper, that movement around is what gives us electricity and lets us turn on our phones and our computers and our lights and all those cool things.